This video is going to show us how to graph sine and cosine functions. Recall that trig functions are periodic, which means that they repeat every so often. Our standard period for sine and cosine is 2 pi, because that's one whole trip around the circle. So these are our basic guidelines for sketching a graph of sine and cosine functions. We're going to start by identifying the period. The period is always equal to 2 pi divided by b. Now, where that's coming from is the b in our equation. So we know from graph by transformation that b value is a horizontal expansion or compression, that we always divide our x values by whatever that number is. So what we're doing here is we're just taking care of that horizontal expansion or contraction from the beginning. So our period is 2 pi divided by b. We're then going to divide our period up into 4 equal parts. Next, we'll identify the amplitude. The amplitude is the absolute value of a. Amplitude is the max height or the lowest height of our graph. It's the distance between our midline and the top or the bottom. So the a, where that's coming from, if you notice, that's the multiplier out in front, and we know from graph by transformation that that's a vertical expansion or contraction. So our amplitude brings that to our attention. Then we're going to graph y equals a sine of bx or y equals a cosine of bx. We'll then identify the phase shift and shift it. A phase shift is simply a horizontal shift, and we know from transformation that horizontal shifts happen when we have plus or minus a number inside the function, which is what the c is. But to get the phase shift, we need to take c and divide it by the absolute value of b. When we typically do graph by transformation, we do a horizontal shift before we do a horizontal expansion or contraction. But because we're kind of doubling up transformations here, we have to take in consideration that division by b, and that's what's happening with the phase shift. So c divided by b, and then lastly, we'll identify the vertical shift and shift it vertically, and that's going to be the plus d on the outside. Let's graph 2 periods of y equals -4 cosine of x. The first thing we're going to do is identify the period, which is going to be equal to 2 pi over b. B in this example is just 1, so we get a period of 2 pi. So starting from the origin, we're going to go out to our 4th mark, and that will be 2 pi. We're going to divide this into 4 equal parts. Here, 1, 2, 3, 4 equal parts. To get the numbers for these tick marks, we're actually going to get the second one first, and we do that by just taking our period and dividing it by 2, so this one will be pi. And then to get the first one, we divide that second one in half, and that'll be pi over 2. And then to get the third one, we multiply the first one by 3. 3 pi over 2. And then once we have these ones, it'll just be the negative going to the left. Next, we want to identify the amplitude. The amplitude is the absolute value of a, so the amplitude is going to be the absolute value of -4, which is 4. So that tells us the height of our cosine graph. And now we want to graph. Cosine always, always, always starts at your a value. Since a is -4, we're going to be starting at -4. -4 is the minimum value of our graph. We know that from our amplitude. So if this is the lowest possible value our graph is going to have, our graph has nowhere to go but up. So we're going to go up, and we're going to be at 0 at pi over 2, and then we're going to go up to our max value of 4 at pi. Since we are at our max value, we have nowhere to go but down, so we're down to 0 at 3 pi over 2, and then all the way down to -4 at 2 pi. And then we want to repeat this pattern going in the negative direction. So we're back at 0 here, we're at -4, so I'm going to go up to 0, up to +4, that's our max value, so we have to come back down to our middle line, and then down to -4 at -pi over 2, and we're ready to connect our dots. This should be a curve and not like a V shape. It shouldn't look like shark teeth. This graph does not have a phase shift or a vertical shift, so this is just it. This is the graph of y equals -4 cosine of x. Next, let's graph y equals sine of 2/3 x. We're going to start by identifying the period, which is 2 pi divided by b. B in this example is 2/3. We'll multiply by the reciprocal here. Our 2's cancel out, and we're left with 3 pi for our period. So from the origin, our fourth mark out then is going to be 3 pi. We'll divide this in half to get the second tick mark, 3 pi over 2. We'll divide that in half to get the first tick mark, 3 pi over 4. And then to get the third one, we'll multiply the first one by 3. So that'll be 9 pi over 4. And then the other ones are just in the opposite direction, the negatives. Great. Now we want to identify the amplitude. It's the absolute value of A, and our A value this time is 1. You'll notice that this one, like the other one, does not have a phase shift or a vertical shift, so this will only involve one graph. Our max height is 1, our minimum height -1, and we're ready to graph. Sine always, always, always starts at 0. When your A value is positive, sine starts by going up. See, with cosine, we didn't have an option because we were starting at either the max number or the minimum value. But with sine, you have an option since we're starting at 0 to either go up or down first. And the sine, SIGN, of our A value makes that decision for us. So if A is positive, you go up first. If A is negative, you go down first. Since A was positive, we're going to go up first. And now we are at our max height of 1, so we have to go down. And we continue to go down until we reach our minimum value of -1, and then we come back up. And then we'll repeat this pattern going the opposite direction as well. Now that we have our points, we're ready to draw in our sine graph. And there we have it. The graph of y equals sine of 2/3 x. Next, we're going to take a look at one with some additional transformations to it. So you'll notice that this example for the first time has a c value. So this is going to involve more than one graph. We're going to need two graphs here. So I think I'm going to write out a little bit of a plan. First, we're going to graph y equals negative sine of 2x, and then we'll have the horizontal shift, and that'll be y equals negative sine of 2x minus pi. Okay, so for our green graph, the first thing we need is our period, 2 pi over b. That's going to be 2 pi over 2, so we get a period of pi. That means our force mark is pi, and I will divide it up. Dividing it by 2, I get my second mark to be pi over 2. Dividing that by 2, we get pi over 4. To get our third mark, we multiply the first one by 3. Going to be 3 pi over 4. And then we'll have the opposites to the left. Next, we want to identify our amplitude. Our amplitude is equal to the absolute value of A. A is negative 1 this time. So our amplitude is 1, letting us know our max and minimum height. And now we're ready to graph our green graph. Sine always starts at 0. We go up if our A value is positive, and we go down if our A value is negative. And recall from graph by transformation, multiplication by a negative out in front is a vertical reflection. So instead of sine, which typically goes up first, it's going to reflect vertically, which causes it to go down first. So that's why if it's negative, we're going to go down. I'm going to go down, and I've reached my minimum value, so now I need to come back up. Once I reach my max value, I come back down. And then we're going to repeat this pattern in the negative direction as well. And we connect our dots. And there we have the graph of y equals negative sine of 2x. But we're not done. Right? This graph has a phase shift. So to find our phase shift, we take c and divide it by the absolute value of b. So that's going to be pi over 2. And just like with graph by transformation, we go in the opposite direction of the sign we see. So since it's minus pi, we're going to go to the right. Now I'm always happy when my phase shift is one of the numbers that I've put on the graph, like one of my tick mark numbers, because then it's much easier to do the shift. Pi over 3 would not have been fun to do. So pi over 2, you'll notice that that's the second tick mark from the origin. So that means that we are moving all of our points 2 tick marks to the right. So I'm taking all my green points, and everybody's getting moved 2 tick marks to the right. And once you get a few of them, you kind of see what the wave pattern is. So like by now, I can kind of see that, oh, I need to do this. Right? So I'm gonna get the points just following the pattern. And now that we have all of our red points, I'm ready to draw in my graph. And there we have it in red, y equals negative sine of 2x minus pi.